Welcome, and thanks for being here. You can get comfortable. There's nothing you need to do right now. No need to focus too much. Just let the words be in the background. Some thoughts might catch your attention, others might drift away, and that's perfectly fine. If you enjoy this kind of calm space, you can leave a like to support the channel and subscribe if you'd like to come back again. It really helps, and it keeps this space going. For now, just take it easy. Let the sound settle, let the day fade a little, and allow yourself to rest. The question of why the universe exists at all is one of the oldest and most persistent questions human beings have ever asked, and it arises naturally from a simple moment of awareness, the realization that something exists rather than nothing. And while this realization can feel abstract, it points to a concrete physical fact that there is a universe, that it contains energy, matter, space, and time, and that these elements behave according to stable patterns we call physical laws. And before we explore deeper explanations, it is important to begin with a calm and careful definition of what we mean by existence. Because in physics, existence does not imply purpose, intention, or meaning, and it does not imply that something exists for a reason in the human sense. And instead, existence simply refers to the presence of physical reality, a state in which energy, fields, and space-time are present and capable of change. And this distinction is important because many misunderstandings arise when human ideas about meaning are projected onto physical processes. And in scientific terms, the universe exists because physical reality is present, and the task of physics is not to assign purpose, but to describe behavior, structure, and consistency. And when we ask why the universe exists, physics approaches the question by asking how existence behaves, how it evolves, and what rules govern it. And this approach has revealed something quietly profound, that existence appears to be self-consistent, meaning that the universe follows rules that allow it to persist without external support. And this does not yet explain why those rules exist, but it establishes that the universe does not appear fragile or temporary by default. And another important starting point is to recognize that the concept of nothing is not as simple as everyday language suggests, because in common speech, nothing is imagined as empty space, darkness, or absence. But in physics, empty space is not nothing, and darkness is not nothing. And even a region with no particles still contains physical structure in the form of fields and energy. And this means that when we talk about nothing in a strict sense, we are talking about the complete absence of anything at all. No space, no time, no fields, no laws, no structure. And this kind of absolute nothingness is not something physics has ever observed, and not something physics currently knows how to describe mathematically. And this immediately shifts the question because it suggests that nothing may not be a physically meaningful state. And if nothing is not a physically meaningful state, then existence does not require a transition from nothing, and instead may be the default condition. And this is a subtle but powerful idea because it reverses the usual assumption. And instead of asking why something appeared out of nothing, we begin to ask whether nothing was ever a real possibility at all. And this reframing will guide the rest of the series as we slowly explore what modern physics suggests about existence, stability, and why a universe may be more natural than absolute nothingness. To continue gently, it helps to clarify what we mean by the universe itself, because the word universe is often used loosely, and different meanings can quietly shift the direction of the question. And in physics, the universe does not mean only galaxies, stars, and planets, but refers to the totality of physical reality, including space, time, energy, matter, and the fields that give rise to particles. And this totality is treated as a single connected system. And within this system, every physical process is an expression of underlying structure. And this structure appears to be governed by consistent mathematical relationships. And these relationships are what we call physical laws. And it is important to notice that physics does not describe the universe as an object placed inside a larger container, and it does not describe the universe as something sitting in an external space. And instead, space itself is part of the universe, and time itself is part of the universe. And this means that asking why the universe exists is not the same as asking why a particular object exists, because there is no larger physical environment within which the universe is embedded. And this distinction matters because many intuitive ideas about causes depend on one thing existing within a larger background, and that background supplying the conditions for existence. And in the case of the universe, there is no known external background, and this already suggests that existence at the most fundamental level may not operate according to everyday notions of cause and effect. And another important aspect of the universe as described by physics is that it behaves as a continuous process rather than a static object, and everything within it is constantly changing, interacting, and evolving. And this ongoing activity is not something added on to existence, but is part of what existence means in physical terms. And when we look at the universe this way, existence appears less like a singular event and more like an ongoing condition. And this naturally leads to the idea that asking why the universe exists may be closer to asking why physical processes occur at all. And physics approaches this by studying patterns rather than purposes. And these patterns show remarkable consistency. And this consistency suggests that existence is not accidental in a fragile sense, but stable in a structural sense. And this stability becomes important when we later examine the idea of nothing itself. Because if existence is stable, then the absence of existence would need to be equally stable in order to be a meaningful alternative. And so far, physics has found no evidence for such stability in absolute nothingness. And this gradually guides us toward a picture in which the universe exists because physical reality is what there is, and not because it was selected from among many equally possible states. And holding this idea quietly in mind prepares us to explore the concept of nothing itself, and why it may be far less straightforward than it initially appears. Now we turn gently toward the concept of nothing, because much of the mystery surrounding existence arises from assumptions about what nothing means. And in everyday language, nothing is often imagined as empty space, silence, darkness, or absence of objects. And these images feel intuitive. But in physics, none of these situations qualify as true nothingness. An empty space still contains space, still has volume, still has measurable properties, and still supports physical fields. And darkness is simply the absence of visible light, not the absence of physical reality. And even a perfect vacuum in which no particles are present is not nothing, because quantum fields still exist there. And these fields carry energy and structure, and they can produce measurable effects. And this means that what humans usually picture as nothing is actually a form of something. And when we speak about nothing in a strict philosophical or physical sense, we are referring to the complete absence of anything whatsoever. No space, no time, no energy, no fields, no laws, no structure. And this type of absolute nothingness is not something physics has ever observed, and not something that appears in any established physical theory. And this absence of absolute nothing from physical description is significant, because physics describes what exists and how it behaves, and if absolute nothingness cannot be described, modeled, or tested, then its status as a physically meaningful possibility becomes questionable. And this does not prove that absolute nothingness is impossible, but it does suggest that nothingness does not belong naturally within the language of physics, and instead belongs to philosophical abstraction. And this distinction matters because when we ask why the universe exists instead of nothing, we are comparing a well-defined physical concept to an undefined or poorly defined one, and this makes the question asymmetrical from the start. And recognizing this asymmetry gently shifts our thinking because it suggests that existence may not require an explanation in terms of nothing, and instead may simply be the baseline condition described by physical theory. And if this is the case, then the universe existing is not a surprising exception, but the normal state of affairs. And this perspective will become increasingly important as we explore how modern physics treats empty space, vacuum energy, and quantum fields, and how these concepts further blur the boundary between something and nothing. With this softer understanding of nothing in place, we can now return to the idea of existence itself and examine it not as a mysterious accident, but as a physical condition that appears to possess internal consistency and stability. And in physics, stability is an important concept because stable systems are systems that persist without requiring continuous external support. And many physical structures exhibit this property, from atoms to stars to galaxies. And they persist because the forces and laws governing them balance in ways that allow long-term continuation. And when we apply this idea to the universe as a whole, a similar pattern appears, because the universe behaves as a self-contained system whose evolution is governed by internal rules. And these rules do not appear to require an external agent to keep operating. And this observation quietly changes the tone of the question, because instead of asking why something was created, we begin to ask whether existence itself may be a stable state. And if existence is stable, then its persistence does not require constant explanation, in the same way that a stable object resting on a table does not require continuous justification for why it remains there. And another important point is that physical laws do not behave like fragile instructions that could easily fail, and instead they appear deeply woven into the structure of reality. And wherever we look in the universe, we observe the same fundamental patterns, the same relationships between energy, matter, and motion. And this universality suggests that physical law is not an optional feature, but an intrinsic feature of existence itself. And if laws are intrinsic, then existence and lawful behavior are inseparable. And this further supports the idea that existence is not a temporary or accidental condition, but a coherent and self-sustaining one. And from this perspective, asking why the universe exists begins to resemble asking why stability exists, or why structure exists. And physics addresses these questions by uncovering deeper layers of pattern rather than invoking external causes.
And this approach does not produce a single dramatic answer, but it produces a gradually deepening picture in which existence appears as a natural outcome of consistent structure. And this does not yet tell us why these particular laws exist rather than others, but it does tell us that once laws exist, existence follows naturally from them. And this is a crucial step, because it suggests that the real mystery may not be why something exists instead of nothing, but why the universe has the specific structure that it does. And this subtle shift moves the question from absolute existence versus non-existence toward the character of physical law itself. And this shift will guide the next stages of our exploration.
From here, we can begin to explore one of the most quietly influential ideas in modern physics, which is that energy lies at the foundation of physical existence. And energy in physics is not simply fuel or power, but a conserved quantity that appears in many different forms, including mass, motion, radiation, and field excitations. And every physical system that has been studied can be described in terms of energy transformations. And this universality suggests that energy is not a secondary feature layered on top of existence, but a primary aspect of what existence is. And this becomes especially relevant when considering why something exists rather than nothing, because if energy is fundamental, then the absence of energy would correspond to the absence of physical reality. And yet physics has never observed a state in which energy is truly absent. And even the lowest energy states allowed by quantum theory still contain fluctuations. And this observation gently points toward the idea that zero energy may not be a physically realizable condition. And if absolute zero energy cannot exist, then absolute nothingness cannot exist either, because nothingness would require the absence of all energy. And this line of reasoning does not rely on speculation, but on well-tested features of quantum field theory, which describes empty space as possessing a baseline level of activity. And this baseline activity is not added by observers and does not depend on measurement, and instead appears as an intrinsic feature of the mathematical structure of the theory. And another important point is that conservation laws, such as conservation of energy, suggest that physical quantities cannot simply appear or disappear without constraint. And this reinforces the idea that existence operates within a closed logical framework rather than emerging from a featureless void. And within this framework, asking why energy exists may not be meaningfully different from asking why physical law exists, and physics currently treats both as fundamental inputs rather than derived outcomes. And this may feel unsatisfying, but it reflects the honest boundary of current knowledge. And within that boundary, what can be said is that physical theory does not point toward a universe arising from literal nothingness, and instead points toward a universe arising from underlying structure that already contains energy, law, and stability. And this supports the growing picture that something is natural, while nothing may be an abstraction without physical counterpart. And this idea will become clearer as we move into a closer look at vacuum energy and quantum fields. To understand why modern physics does not treat empty space as nothing, we need to look more closely at the concept of the vacuum. And in everyday language, a vacuum means an empty region with no matter inside it. But in physics, the vacuum refers to the lowest energy state of a system, not the absence of the system itself. And this distinction is essential because even when a region contains no particles, the fields that give rise to particles are still present, and these fields have measurable properties.
And according to quantum field theory, these fields cannot be perfectly still, and instead they undergo small, unavoidable fluctuations. And these fluctuations are not artifacts of measurement, but arise from the mathematical structure of the theory itself, and they lead to observable effects, such as slight shifts in atomic energy levels and measurable forces between objects placed very close together. And these observations confirm that so-called empty space contains physical activity. And this means that the vacuum is better described as a dynamic background rather than an empty void. And this dynamic background exists everywhere in the universe and has existed throughout cosmic history. And this quietly undermines the idea that the universe emerged from absolute nothingness, because even the simplest state allowed by physics already contains structure, energy, and law. And another important point is that quantum fields do not appear to require an external cause to exist. And within the framework of the theory, fields are simply part of what the universe is. And asking why fields exist is similar to asking why space exists or why time exists. And physics does not currently derive these from deeper principles, but treats them as fundamental aspects of reality. And this suggests that existence may not originate from a prior absence, but may be self-contained. And this idea does not solve every mystery, but it steadily erodes the assumption that nothingness is a natural or default state, and instead supports a picture in which physical structure is primary, and absence of structure may not be physically meaningful. And with this understanding, we can begin to explore why absolute nothingness may not only be unobserved, but unstable or impossible within known physics.
The idea that absolute nothingness might be unstable may sound unfamiliar at first, but it follows naturally from what we have already explored. Because if the lowest energy states allowed by physics still contain structure and fluctuation, then a state with literally no structure would not fit into the framework of known physical law. And instability in physics refers to a situation in which a state cannot persist and instead transitions into another state. And many unstable states exist in nature, such as excited atoms that release energy, or unstable nuclei that decay. And they all share a common feature, which is that they are allowed by physical law to change into more stable configurations. And when we ask whether absolute nothingness could be a stable configuration, we immediately encounter a problem, because nothingness contains no laws, no fields, and no structure to define what stability would even mean. And without law, there is no rule set that could enforce persistence. And this alone suggests that absolute nothingness may not qualify as a physical state at all. And in contrast, existence, as described by physics, is governed by mathematical relationships that define how systems behave, and these relationships provide a form of structural stability. And another way to express this is that physics describes a universe in which structure supports itself, rather than a universe that must be constantly sustained by something external. And within this view, nothingness is not a competing alternative to existence, but an undefined concept outside the scope of physical description. And this reframing is important because it removes the intuition that nothing is the natural baseline from which something must be explained, and instead suggests that something may be the only physically meaningful baseline. And this does not claim that we have proven nothingness impossible in an absolute philosophical sense, but it does show that nothingness does not appear as a viable state within our best physical theories. And this alone shifts the balance of the original question and gradually moves us toward the idea that the universe may exist because physical reality is what there is, rather than because something emerged from a prior absence. And with this groundwork in place, we can now begin to explore how time fits into this picture and whether existence itself may be timeless in some deeper sense.
Time occupies a central place in any discussion about existence because many intuitions about beginnings and origins rely on temporal thinking, and we naturally imagine a moment before which nothing existed, followed by a moment when something appeared. And this intuitive picture is shaped by everyday experience, where objects come into being within an already existing timeline. And however, modern physics suggests that time itself is part of the universe, rather than a container in which the universe sits. And this distinction is subtle but crucial, because if time is part of the universe, then asking what happened before the universe may not be meaningful in the usual sense. And this is similar to asking what is north of the North Pole. And within general relativity, time is woven together with space into a single structure called space-time. And this space-time evolves as the universe evolves. And according to current cosmological models, the early universe was extremely hot and dense, and space-time itself was in a very different condition than it is today. And this suggests that time, as we experience it, may have emerged gradually rather than existing as an infinite background. And if time itself has a beginning or a boundary, then the question of why the universe exists cannot be framed as a simple event occurring at a moment in time, because there would be no earlier time in which nothing existed. And this perspective further weakens the idea that the universe emerged from nothing at a specific instant, and instead supports the idea that existence may be a fundamental feature of reality that does not require a temporal starting point in the usual sense. And this does not mean that we fully understand the origin of the universe, but it does mean that our everyday concept of beginnings may not apply at the deepest level. And this realization gently pushes the discussion away from creation narratives and toward structural descriptions, and prepares us to look more closely at how cosmology interprets the Big Bang, not as an explosion from nothing, but as an expansion of space-time itself.
When the term Big Bang is used in popular language, it often creates the image of a small object exploding outward into empty space. But this image is misleading, and modern cosmology does not describe the Big Bang as an explosion occurring at a point within space, and instead describes it as a rapid expansion of space itself. And this distinction is essential, because it means that the Big Bang does not represent matter flying into pre-existing emptiness, but represents space-time evolving from an extremely dense and hot state into the larger, cooler universe we observe today. And within this framework, every region of space was once compressed into a much smaller volume, and the expansion occurred everywhere at once, not from a central location.
And this model is supported by multiple independent observations, including the expansion of galaxies, the cosmic microwave background radiation, and the relative abundances of light elements. And all of these observations point to an early universe that was dense, energetic, and structured, not empty. And this directly challenges the idea that the universe began as nothing, and instead suggests that the earliest stage we can describe was already something. And although current physics cannot describe conditions earlier than a certain limit, this limit represents a boundary of knowledge, not a confirmed boundary of existence. And this distinction matters because it prevents us from equating unknown with non-existent. And another important point is that even at the earliest times we can model, physical laws appear to operate, and particles, fields, and interactions can be described within those laws. And this reinforces the idea that existence is deeply connected to lawfulness, and that wherever physical law applies, physical reality is present. And this view does not answer every question about ultimate origin, but it steadily removes the assumption that the universe emerged from literal nothingness, and replaces it with a picture in which the universe has always been in some physical state, even if that state is very different from anything we currently experience. And with this understanding, we can begin to explore whether the universe requires a cause in the traditional sense, or whether causation itself may be a concept that only applies within the universe rather than to the universe as a whole.
The idea that everything must have a cause is deeply rooted in human intuition, because in everyday experience, events appear to follow from prior events, and this pattern becomes a basic framework for how we understand the world. And however, physics suggests that causation may not operate in exactly the same way at the most fundamental level. And this has important implications for the question of why the universe exists. And within the universe, we observe chains of cause and effect, where physical processes influence one another in lawful ways, and these chains can often be traced backward in time. And yet, when we attempt to apply this same reasoning to the universe as a whole, we encounter conceptual difficulties, because causation as we understand it is defined within space-time. And if space-time itself is part of the universe, then asking for a cause outside of space-time may not be meaningful in the usual sense. And this does not mean that the universe is uncaused in a simplistic way, but it does suggest that the concept of cause may have a limited domain of applicability. And another important point is that physics already contains examples of processes that do not have a single specific cause in the classical sense, and instead occur probabilistically, such as radioactive decay. And while these processes are governed by physical law, the exact timing of an individual event cannot be predicted. And this shows that not all physical events require a precise triggering cause, and this observation further weakens the assumption that the universe itself must have a cause in the same way that everyday events do. And taken together, these ideas suggest that existence may not require an external cause in order to be meaningful, and instead may be a fundamental feature of reality. And this does not solve the mystery in a dramatic way, but it gently shifts the question from why did something appear to what kind of structure allows something to exist at all.
And this shift moves us away from origin narratives and toward structural explanations, which is the natural language of physics.
With these ideas in place, we can now begin to explore the possibility that the universe may be a self-existing system, meaning a system that does not rely on anything outside itself in order to exist. And in physics, a closed system is one that does not exchange energy or information with anything external. And when we apply this concept to the universe, it becomes unique because by definition, there is nothing outside the universe with which it could exchange anything. And this makes the universe the ultimate closed system. And within such a system, all physical processes arise from internal structure and internal law. And this perspective naturally leads to the idea that existence may be self-contained and not dependent on external support. And another important point is that many fundamental physical laws appear to be global in nature, meaning they apply everywhere and at all times. And this universality suggests that the laws are not local features attached to specific regions, but intrinsic features of the universe as a whole. And if laws are intrinsic, then existence and lawfulness are inseparable. And this further supports the idea that the universe does not require an external explanation in the same way that objects within the universe do. And within this framework, asking why the universe exists may be similar to asking why mathematical consistency exists. And physics currently treats consistency as a foundational principle rather than something derived. And this may feel incomplete, but it reflects the boundary of what can be meaningfully addressed within scientific methodology. And within that boundary, what can be said is that the universe behaves like a system whose existence is not contingent on external conditions. And this behavior aligns with the growing picture that something is natural, stable, and self-consistent, while absolute nothingness is not represented anywhere in physical theory. And this contrast continues to strengthen the idea that nothing may not be a real alternative to existence, but an abstract concept without physical counterpart. Another layer of this discussion involves conservation laws, because conservation laws describe quantities that remain constant over time within a closed system. And among the most fundamental of these is the conservation of energy. And this law states that energy cannot be created or destroyed, but only transformed from one form into another. And while the precise formulation of this law becomes more subtle in cosmology, the general idea that physical quantities obey deep structural constraints remains central. And these constraints suggest that physical reality is not arbitrary, but organized around persistent patterns. And this persistence is closely related to the stability of existence. And if certain quantities must always be conserved, then the universe cannot simply dissolve into nothingness, because nothingness would violate these structural relationships. And another important point is that conservation laws are not imposed from outside the universe, but arise from symmetries within the structure of physical law itself. And this means that stability is built into the fabric of reality, rather than added afterward. And this further supports the idea that existence itself is not a fragile accident, but a robust condition. And within this framework,
The universe does not need to be continuously sustained by an external agent and does not require constant input in order to remain real, and instead persists because its internal structure allows persistence. And this does not explain why these particular symmetries exist, but it does show that once they exist, stable reality follows naturally. And this pattern repeats throughout physics, where deeper layers of structure explain the stability of higher-level phenomena. And this layering suggests that existence itself may be the most basic layer, with no deeper external explanation available. And while this may feel unsatisfying, it reflects a consistent feature of scientific inquiry, that some elements are treated as fundamental, and this treatment does not diminish their reality, but acknowledges the limits of explanation. We can now turn gently toward the question of why physical laws exist at all, because throughout this exploration, physical laws have appeared as central actors, and it is natural to wonder whether laws themselves require an explanation. And in physics, laws are not treated as commands imposed on reality, but as descriptions of regularities observed in nature. And when a pattern is found to hold consistently across many different conditions, it is summarized in mathematical form. And this mathematical form becomes what we call a law. And this perspective suggests that laws do not exist separately from reality, but are expressions of reality's structure. And in this sense, asking why laws exist may be equivalent to asking why reality has structure. And physics does not currently provide a deeper answer to this question, and instead treats structured behavior as a fundamental feature of existence. And this treatment is similar to how geometry treats space, or how arithmetic treats numbers as basic elements that are not derived from simpler physical causes. And this does not mean that deeper theories will never be developed, but it does mean that at present, structure itself is taken as a starting point. And this starting point aligns with the broader theme that existence may be primary rather than derivative. And another important observation is that many different mathematical structures could, in principle, exist, but only some would allow stable, long-lasting systems. And the fact that we observe a universe capable of sustaining complexity suggests that its underlying structure is compatible with stability. And this does not require intentional selection and does not imply purpose, but simply reflects the fact that unstable structures would not persist long enough to be observed. And this idea further weakens the intuition that the universe must have been chosen or designed in order to exist, and instead supports a picture in which stable structure naturally persists and unstable structure naturally fades. And this pattern, once again, points toward existence as a natural outcome of consistency rather than an improbable accident. At this stage, we can consider the idea that reality may be fundamentally mathematical in character, not in the sense that numbers exist independently as physical objects, but in the sense that the behavior of physical systems is deeply described by mathematical relationships. And throughout the history of physics, increasingly abstract mathematics has proven remarkably effective at predicting how nature behaves, often before experimental confirmation. And this effectiveness suggests that there is a deep correspondence between mathematical structure and physical structure, and some physicists interpret this as evidence that reality itself may be a form of mathematical structure. And while this idea remains speculative, it offers an interesting perspective on the question of existence. Because mathematical structures do not require a physical substrate in order to be consistent, and they exist as logical possibilities. And if physical reality corresponds to one such structure, then existence may be understood as the realization of a consistent mathematical pattern. And within this view, asking why the universe exists becomes similar to asking why a particular mathematical structure is realized rather than none. And this question may not have a meaningful answer within physics, because physics can describe the structure but cannot step outside all possible structures to explain why one is selected. And this limitation does not undermine the reality of the universe, but highlights the boundary between physics and metaphysics. And within physics, what matters is that the structure exists and behaves consistently. And this perspective again points away from the idea that existence is a rare event emerging from nothing, and toward the idea that consistent structure naturally corresponds to existence. And this idea remains one of several ways to conceptualize the deep connection between law, structure, and being. And it continues to support the growing picture that something may be more than nothing.
Another perspective that quietly supports this picture comes from considering how the universe behaves as a whole, rather than focusing only on its earliest moments. And observations indicate that the universe has persisted for billions of years, undergoing continuous change while maintaining overall coherence. And this long-term persistence suggests that existence is not precarious and that the universe is not constantly on the verge of dissolving into nothingness, and instead appears to occupy a stable region of possibility space. And stability in physics is not mysterious, but arises when systems occupy states that are allowed and supported by their governing laws. And when unstable states occur, they tend to transition into more stable configurations. And this general principle suggests that if absolute nothingness were an available state, it would need to be stable in order to persist. And yet physics offers no indication of such stability, and instead shows that even the lowest energy states contain activity. And this reinforces the idea that nothingness is not favored by physical law. And another important observation is that the universe appears to be self-organizing in the sense that complex structures can emerge from simple initial conditions through natural processes. And this self-organization does not require external direction, and it does not require the injection of meaning or intention, and it follows directly from the interactions described by physical law. And this capacity for self-organization further supports the idea that existence is not an anomaly, but a natural outcome of consistent structure. And this does not remove all mystery, but it reframes the mystery away from why something exists and toward why the universe has the particular structure that it does. And this reframing continues to guide us gently toward a view in which nothingness plays little or no role in physical explanation, and existence stands as the primary fact. At this point, it becomes useful to address a subtle but important assumption that often goes unnoticed, which is the assumption that nothingness is simpler than existence, and in everyday thinking, nothing feels simple while something feels complex, and this intuition can quietly bias our reasoning. And however, when we examine the concepts more carefully, the situation becomes less clear, because nothingness
if taken seriously as the absence of everything, would require the absence of space, time, law, structure, and possibility. And such a condition is not merely empty, but undefined, and something that is undefined cannot be described, modeled, or even coherently specified. And in contrast, existence, while complex, is at least describable in terms of structure and relationship. And this suggests that nothingness may not be simpler than existence, but conceptually more problematic. And if nothingness cannot be coherently specified, then it cannot serve as a meaningful baseline from which existence must be explained. And this realization further weakens the intuitive force of the question, why something instead of nothing, because it shows that the comparison itself may be ill-posed. And instead of comparing existence to nothingness, physics naturally compares different possible structures of existence and asks which are stable, which are consistent, and which are allowed by physical law. And within this framework, existence does not need to be justified relative to nothingness, and instead stands as the starting point of inquiry. And this shift in perspective does not solve every deep question, but it brings the discussion into closer alignment with how physics actually operates. And it supports the growing theme that nothingness is not a physical competitor to existence, but a conceptual abstraction with no clear role in physical theory.
Another angle from which to approach this topic is to consider possibility itself. Because when we say that something could exist or could fail to exist, we are implicitly assuming a space of possibilities within which such alternatives make sense. And in physics, possibility is not defined by imagination, but by consistency with physical law. And a state is considered physically possible if it can be described by a mathematically consistent model that obeys the known constraints of the theory. And when we apply this standard to absolute nothingness, we encounter a difficulty, because nothingness contains no structure, and therefore no laws. And without laws, there is no framework within which possibility can be defined. And this suggests that nothingness is not merely unlikely, but undefined in physical terms. And in contrast, existence as described by physics is a fully specified domain with laws, symmetries, and relationships. And within this domain, many different states are possible. And this asymmetry between existence and nothingness is important, because it shows that existence belongs to the space of physically meaningful possibilities, while nothingness does not clearly belong to that space at all. And this further supports the idea that asking why the universe exists instead of nothingness may be similar to asking why triangles exist instead of non-geometric absence. And the question loses traction because one side of the comparison lacks definition. And this does not claim that we have proven nothingness impossible in an ultimate sense, but it does show that nothingness plays no constructive role in physical explanation. And physics naturally operates within the domain of structured possibility, and within that domain, existence is the baseline. And with this understanding, we can begin to explore how persistence arises and why something, once it exists, tends to continue existing rather than vanishing.
Persistence is one of the most quietly remarkable features of the universe, because once physical systems form, they tend to continue existing,
unless acted upon by specific interactions that change their form. And even then, they do not vanish into nothingness, but transform into other configurations. And this pattern holds at every scale, from subatomic particles to stars and galaxies. And this universal tendency toward transformation rather than annihilation reflects a deep principle of physics, that physical quantities are conserved and redistributed rather than erased. And this principle suggests that existence has an internal continuity, and that continuity does not require constant justification. And another way to express this is that physics describes a universe in which change operates on existing substance, rather than a universe in which substance itself flickers in and out of being. And this observation further weakens the intuition that nothingness is a natural resting state, and instead supports the idea that existence is self-maintaining. And within this view, the universe does not need to be continually held in existence by something else, but persists because its internal structure allows persistence. And this does not eliminate mystery, but it reshapes it. And instead of asking why existence exists at all, we begin to ask what features of structure allow continuity. And physics answers this by pointing to symmetries, conservation laws, and stable interactions. And this layered explanation aligns with everything we observe and continues to support the picture that something is natural, while nothingness is not represented within physical law.
With persistence in mind, we can now gently explore the idea that existence may not only be stable, but self-consistent, meaning that the structure of reality does not merely survive, but fits together in a way that does not require external correction or reinforcement. And self-consistency in physics refers to the absence of internal contradictions within the governing equations and principles. And when a theory is self-consistent, it does not produce results that violate its own assumptions. And modern physical theories, while incomplete, display a remarkable degree of self-consistency. And this suggests that the universe is not a patchwork of unrelated rules, but a coherent system whose parts mutually support one another. And this coherence matters when thinking about why the universe exists, because a self-consistent system does not require an external stabilizer in order to remain meaningful. And another way to express this is that the universe does not appear to be balanced on the edge of non-existence, but instead occupies a mathematically stable region of possibility. And within this region, physical processes unfold naturally according to their internal relationships. And this stands in contrast to the intuitive picture in which existence must be constantly defended against collapse into nothingness. And physics offers no evidence for such a collapse tendency, and instead shows that transformation, not disappearance, is the dominant mode of change. And even in extreme events such as particle annihilation, the result is not nothing but radiation, and energy continues to exist in a different form. And this universal pattern of conversion rather than erasure strongly suggests that nothingness is not an attractor state for physical reality. And if nothingness is not an attractor, then existence does not require continuous explanation for why it has not disappeared. And this realization quietly shifts the question again, because instead of asking why existence persists, we can acknowledge that persistence is built into the structure of physical law.
And the deeper question becomes why such a structure exists at all. And physics currently treats this as a foundational fact rather than a derived one. And this may feel incomplete, but it reflects a consistent pattern in science, where explanations ultimately rest on certain primitives, and those primitives are not arbitrary, but chosen because they successfully organize experience. And in this sense, existence may be one of those primitives and not something that can be reduced to a simpler cause. And this perspective continues to support the growing theme that something does not need to be justified against nothing, because nothing does not function as a physically meaningful alternative within our best understanding of reality.
Another quiet implication of everything we have explored is that existence may not be a binary state in the sense of being either fully present or fully absent, but may instead be better understood as a continuous spectrum of structure. And physics often describes systems in terms of degrees, intensities, and distributions rather than absolute on or off states. And this pattern suggests that reality is composed of varying levels of organization rather than a sharp divide between being and non-being. And for example, matter can exist in many forms, from dense solids to diffuse gases to high-energy plasma. And fields can exist in states ranging from calm to highly excited. And space-time itself can be curved in different ways depending on energy content. And all of these variations occur within existence, not between existence and nothingness. And this observation further weakens the idea that nothingness is a natural partner to existence, and instead suggests that physical reality expresses itself through continuous modulation rather than discrete creation from absence. And another important point is that physics never describes a process in which reality fades into absolute nothing. And even in theoretical scenarios involving extreme cosmic evolution, such as long-term cooling or expansion, physical entities continue to exist in some form. And this persistence across scales and conditions reinforces the picture of existence as a continuous domain. And within this domain, change means rearrangement rather than erasure. And this perspective allows us to see the universe not as something that precariously hangs between being and non-being, but as something that naturally occupies a space of structured possibility. And this space does not appear to include absolute nothingness as a viable point. And recognizing this gently guides us toward a view in which existence is the default condition described by physics, and nothingness is a conceptual contrast without physical counterpart. And this view continues to align with the overall theme that something is natural, while nothing may not be.
At this stage, we can begin to notice that many different lines of reasoning coming from different areas of physics quietly converge on a similar conclusion. And that conclusion is not that we fully understand why the universe exists, but that the idea of the universe existing is far less puzzling than the idea of absolute nothingness. And this reversal is subtle, because human intuition often treats nothing as simple and something as complex, and yet physics suggests the opposite. And something is describable, structured, and governed by law, while nothing lacks definition, lacks structure, and lacks any framework in which it could meaningfully persist. And this inversion of intuition helps explain why physical theory naturally focuses on describing what exists
rather than attempting to derive existence from nothing. And another convergence comes from the success of mathematical description, because mathematics captures regularities that appear deeply woven into physical behavior, and these regularities do not seem to flicker in and out of existence, but remain stable across enormous spans of time and space. And this stability again points toward existence as a robust condition, rather than a fragile anomaly. And taken together, these converging lines do not deliver a dramatic origin story, and they do not claim to solve the ultimate mystery. Instead, they offer a quieter reframing, and that reframing is that existence may be fundamental, and nothingness may not be a meaningful alternative. And this reframing does not eliminate curiosity, but it changes the direction of curiosity. And instead of asking why something appeared from nothing, we begin to ask what kinds of structure are possible, and why the structure we observe has the properties it does. And this shift aligns naturally with how physics actually progresses, by refining descriptions of structure rather than inventing narratives of absolute beginning. And this alignment suggests that the deepest answer available within physics may not be an answer in the form of a story, but an answer in the form of a framework. And within that framework, existence is the starting point, not the conclusion.
With this framework in place, we can gently approach a final distinction that helps organize everything we have discussed. And that is the distinction between explanation and description. And explanation, in everyday language, often implies providing a cause in terms of something else, while description means specifying the structure and behavior of something as it is. And physics excels at description, and uses description to build predictive models. And many times, these descriptions are the deepest form of explanation available within science. And when we ask why the universe exists, we may be unconsciously demanding an explanation in the sense of a cause outside the universe. And physics does not operate with such causes, because all causes described by physics exist within the universe. And this means that physics naturally responds to the question by offering a description of how existence behaves rather than a cause of existence itself. And this does not mean that the question is meaningless, but it does mean that its answer may not take the form we expect. And within physics, the most honest response is that existence is a foundational aspect of reality, and foundational aspects are not derived from deeper physical causes. And this pattern appears throughout science, where certain principles are treated as basic, not because they are arbitrary, but because they consistently organize all observed phenomena. And within this pattern, existence itself may be one of the most basic principles. And this does not close the door to future theories that might deepen our understanding, but it does suggest that seeking a cause of existence in the same way we seek causes of events within existence may be a category error. And recognizing this gently dissolves some of the tension surrounding the original question and allows it to be held as a deep philosophical curiosity rather than a problem that physics has failed to solve. At this point, it becomes appropriate to gather the quiet insights that have emerged and view them as parts of a single coherent picture, without turning that picture into a final or absolute conclusion. And the picture that forms is one in which physical reality exists, persists, and evolves according to consistent internal structure. And this structure does not appear to depend on external support, external intention, or emergence from literal nothingness, and instead appears to be self-contained, lawful, and stable. And within this picture, nothingness does not appear as a physically meaningful state, but as a conceptual contrast that lacks representation in physical theory. And this contrast is important philosophically, but it does not function as a competitor to existence within physics. And this perspective does not claim that we now know why the universe exists in an ultimate sense, and it does not claim that all mystery has been removed. And instead, it claims something more modest, that physics does not point toward a universe arising from nothing, and does not point toward existence being fragile or accidental. And this modest claim is grounded in everything we have examined, from vacuum structure, to energy, to conservation laws, to cosmology, to stability. And taken together, these elements quietly support the idea that something is natural, and nothing may not be. And this idea may feel unfamiliar because it reverses common intuition, but unfamiliarity does not imply error. And throughout the history of science, many accurate ideas have initially felt unintuitive. And with this in mind, we can approach the final parts of the series not in search of dramatic resolution, but with a calm appreciation for the depth of the question and the boundaries of current understanding. As we move into the later stages of this exploration, it becomes valuable to notice a shift that has quietly taken place, because the question has gradually transformed from asking why something exists into asking what existence is like. And this shift is important because it reflects the way physics naturally approaches deep problems. And rather than seeking ultimate origins in the form of singular events, physics tends to seek patterns, relationships, and structures that describe how reality behaves across many scales. And when we look at existence through this lens, we no longer see it as a sudden appearance from absence, but as an ongoing condition characterized by lawful behavior, transformation, and continuity. And this view aligns closely with everything we observe, because nowhere in physical theory do we find a mechanism that turns nothing into something, and nowhere do we find a mechanism that turns something into nothing. Instead, we find transformations, rearrangements, and redistributions. And this consistent pattern suggests that existence operates within a closed domain of physical possibility, and that domain does not appear to include absolute nothingness as a reachable state. And another quiet implication of this is that existence does not behave like a rare outcome that barely succeeded, but like a stable configuration that naturally persists. And this stability does not require purpose, intention, or direction, and it does not imply that the universe is aiming toward anything, and it simply reflects the internal consistency of physical structure. And when structure is consistent, it holds, and when structure is inconsistent, it cannot persist. And this simple principle explains a great deal of what we observe,
And it also reframes the original mystery, because instead of asking why something overcame nothing, we begin to ask why consistent structure exists at all. And physics, at its deepest level, treats consistency as foundational, not derived. And this may feel unsatisfying from a philosophical standpoint, but it reflects a recurring feature of scientific explanation, that explanations eventually rest on primitives that cannot themselves be explained in the same framework. And this does not mean that inquiry stops, but it does mean that some questions change form rather than receive final answers. And within this changing landscape, the idea that nothingness is impossible does not appear as a bold claim, but as a quiet absence, an absence of any place within physical theory where nothingness naturally belongs. And this absence itself becomes meaningful because it tells us something about the shape of reality. And what it tells us is that existence is not an exception, but the baseline. And this understanding continues to gently guide us toward the final reflections of the series.
With this baseline understanding in place, we can now approach a subtle but important emotional dimension of the original question. Because the question of why the universe exists often carries an unspoken sense of unease, as if existence itself requires justification. And this feeling may arise from the way human cognition evolved, because in everyday life we are accustomed to explaining objects in terms of their origins, their makers, or their purposes. And this habit of explanation is extremely useful at the human scale, but it may not translate cleanly to the deepest level of physical reality. And when we carry this habit into cosmology, we may unknowingly impose expectations that do not apply. And physics quietly suggests that existence is not a product in need of an external producer, and not an artifact that requires a maker, and not an outcome that must be justified by appeal to something more fundamental, and instead appears as the most basic layer of description available. And this does not remove curiosity, but it changes its character, and curiosity shifts from demanding a reason for existence to exploring the structure of existence. And this shift can feel like a loss of closure, but it is better understood as a movement toward conceptual maturity. And throughout the history of science, many questions that once seemed to demand ultimate causes gradually transformed into questions about structure and relationship. And this transformation did not diminish understanding, but deepened it. And the same process appears to be occurring here. And rather than discovering a hidden switch that turned the universe on, physics is revealing a web of consistent relationships that simply are. And these relationships do not point backward toward nothingness, but outward toward further layers of structure. And this perspective also aligns with the fact that physical theories grow by unifying patterns, not by uncovering singular moments of absolute origin. And when viewed this way, the persistence of existence becomes less mysterious than the idea that existence could ever be absent. And this quiet reversal may be one of the most important insights modern physics offers on the topic. And it suggests that the universe does not exist because it overcame nothing, but because reality, in its most basic form, is a pattern of consistent structure, and that pattern expresses itself as existence. And holding this idea gently allows us to approach the remaining parts of the series with a sense of calm continuity rather than a search for a final dramatic answer. Another way to deepen this calm understanding is to look at how modern physics treats the concept of beginnings, because beginnings in everyday experience usually involve an object appearing within an already existing environment. And this mental model subtly shapes how we imagine the origin of the universe. And yet physics suggests that the universe does not fit into this everyday template because there is no external environment within which the universe appears, and no external timeline within which it begins. And this means that the word beginning may not carry the same meaning when applied to the universe as a whole. And instead of indicating a moment when nothing became something, a cosmological beginning may indicate a boundary in our descriptions, a point beyond which our current theories cannot reliably reach. And this distinction between a boundary of knowledge and a boundary of existence is essential, because it prevents us from turning ignorance into ontology. And throughout the history of science, many boundaries that once seemed absolute were later understood as limits of existing models rather than limits of reality. And this historical pattern suggests caution in interpreting any current boundary as the edge of existence itself. And when we apply this caution to cosmology, we find that the earliest moments we can describe already contain structure, energy, and law. And this reinforces the idea that existence is present wherever physics can meaningfully speak. And beyond that, physics does not describe nothing but simply remains silent. And this silence does not imply absence, and it does not imply emergence from nothing. It simply reflects the current reach of our models. And another important point is that even speculative theories that attempt to go beyond the standard Big Bang picture, such as those involving quantum gravity, cyclic universes, or emergent spacetime, generally describe transitions between physical states rather than transitions from nothing to something. And this convergence across very different theoretical approaches quietly strengthens the theme that physics does not naturally point toward absolute nothingness as a starting point, and instead consistently frames the universe as existing within some form of physical structure, even if that structure is unfamiliar. And this consistency matters because it shows that the idea of nothingness is not central to how physics thinks about origins. And this again suggests that nothingness is not a foundational concept within physical explanation. And recognizing this allows us to approach the question of why the universe exists with less expectation of a dramatic origin story, and more openness to the possibility that existence is simply the condition in which physical description takes place. And this perspective does not close inquiry, but it grounds inquiry in what physics can actually address, and keeps speculation from drifting beyond meaningful constraint. And in doing so, it continues to support the quiet conclusion that something does not need to defeat nothing in order to be real, because nothing may never have been a meaningful alternative in the first place.
At this point, we can gently acknowledge a recurring pattern in scientific explanation, which is that every layer of understanding eventually rests on certain assumptions that are treated as fundamental, not because they are arbitrary, but because they consistently organize everything else we observe. And in classical mechanics, space and time were treated as fundamental. And later, relativity showed that space-time itself has structure. And in quantum mechanics, fields and probabilities are treated as fundamental. And future theories may reveal deeper layers still. And this pattern suggests that seeking an ultimate explanation in the form of a final cause may not align with how scientific understanding actually develops. And instead, science progresses by uncovering deeper structures and showing how many phenomena arise from a smaller set of principles.
And within this pattern, existence itself may be one of the deepest principles, and not something that can be derived from a simpler physical cause. And this does not mean that curiosity should stop, and it does not mean that philosophical reflection becomes meaningless. It simply means that physics, as a method, may not be equipped to answer why there is something rather than nothing in the same way that it answers why an object falls or why a star shines. And recognizing this helps set realistic expectations, and it allows the question to be held as a profound curiosity rather than as a technical problem awaiting a specific solution. And this reframing does not weaken the significance of the question, but it changes the emotional posture with which we approach it. Instead of urgency for resolution, we adopt patience and openness. And this posture aligns well with the quiet, steady nature of scientific progress. And within this posture, the growing picture remains consistent. And that picture is that existence appears as a stable, structured condition described by physical law, while nothingness does not appear as a defined or supported state within physical theory. And this contrast continues to point toward the same calm conclusion, that something is not an anomaly but the baseline, and nothing may be an abstraction without physical footing. Another gentle way to look at everything we have explored is to consider how deeply the idea of structure is woven into every successful physical theory, because structure appears at every level, from the arrangement of elementary particles to the organization of galaxies. And this layered presence of structure suggests that existence is not a chaotic or arbitrary condition, but an ordered one, even when that order is probabilistic. And order in physics does not mean design or intention, but simply means consistent relationships. And wherever consistent relationships appear, physics finds ways to describe them mathematically. And this mathematical describability itself is a quiet clue about the nature of existence, because it suggests that reality is not a shapeless presence, but a patterned one. And when something is patterned, it naturally resists collapsing into absence, because patterns define internal constraints, and constraints stabilize behavior. And this observation connects back to the earlier idea that nothingness would contain no constraints, no relationships, and no internal rules. And without rules, nothingness cannot be described as stable. And if it cannot be stable, it cannot persist. And this line of reasoning does not rely on speculation about exotic physics, but follows from the simple observation that every known physical state is characterized by structure, and that structure is what allows physics to speak at all. And another way to express this is that physics only knows how to describe things that have form, and absolute nothingness, by definition, would have no form, and therefore lies outside the domain of physical description. And this does not prove that nothingness is logically impossible, but it does mean that nothingness has no operational meaning within physics. And when a concept has no operational meaning, it cannot play a role in physical explanation. And this is why physics consistently builds explanations in terms of transitions between states rather than emergence from nothing. And this consistency across many branches of physics is striking, because it appears even in speculative theories that attempt to go beyond current models. And those theories still describe pre-existing structures, prior states, or underlying frameworks, and none of them rely on a true nothing as a starting point. And this convergence quietly strengthens the idea that existence does not need to be justified against nothingness, because nothingness does not appear as a viable alternative within any known physical framework. And with this perspective, the original question begins to soften. And instead of asking why the universe exists at all, we begin to ask what kind of structure reality has, and how that structure expresses itself. And this shift does not make the universe less mysterious, but it changes the shape of the mystery, and it places the mystery inside existence rather than before it. And this is a significant conceptual movement because it replaces an unanswerable contrast with a fertile field of ongoing inquiry. And this movement continues to guide us quietly toward the later parts of the series, where we will reflect on what can reasonably be said and what must remain open.
As we approach the later portions of this exploration, it becomes increasingly clear that the original question has slowly transformed, not because it has been answered in a final sense, but because its internal assumptions have been gently examined and reshaped. And this transformation itself is meaningful because it reflects how deep questions often evolve in science. And rather than collapsing into a single conclusion, they become more precise, more careful, and more grounded in what can actually be described. And in this case, the question has shifted from why something appeared instead of nothing toward whether nothingness is even a meaningful concept within physical reality. And this shift changes the entire landscape of the discussion, because once nothingness is no longer treated as a viable physical state, existence no longer appears as a rare exception, and instead appears as the only domain in which physical description operates. And within this domain, physics consistently describes change as transformation rather than creation from absence, and destruction as conversion rather than disappearance. And this consistency is not a philosophical preference, but an empirical pattern observed across countless experiments. And another important aspect of this pattern is that physical explanations tend to move inward toward deeper structure rather than outward toward external origins. And when something is not understood, physics seeks more fundamental relationships within reality itself, rather than invoking a background state of non-existence. And this inward movement has repeatedly led to unification, where seemingly different phenomena are shown to arise from a smaller set of underlying principles. And this history suggests that the deepest explanations physics can offer will always be structural rather than origin-based. And this does not mean that the idea of an ultimate origin is meaningless, but it does mean that physics may not be the tool capable of addressing it in the way human intuition expects. And recognizing this helps dissolve a subtle tension, because it shows that the absence of a final answer about why existence exists is not a failure of science, but a reflection of what science is designed to do. And within this design, existence itself appears as the stage on which explanation happens, not as an object requiring explanation in the same category as events within the universe. And this perspective does not remove wonder, but it quiets it, and turns wonder away from the idea of a dramatic beginning and toward the continuous presence of structured reality. And this quiet wonder is perhaps closer to the spirit of modern physics, which finds depth not in singular moments, but in the persistent coherence of patterns. And this coherence, observed everywhere we look, continues to suggest that something is not surprising, while nothing remains an abstraction without physical grounding.
With this quieter understanding in place, we can begin to approach what may be the most stable position that physics offers on this entire topic, which is that existence is not something added on top of reality, and not something triggered by a special event,
but something inseparable from the structure of physical law itself. And this idea can feel unfamiliar because everyday thinking treats existence as a condition that must be switched on. And yet physics does not describe any such switch, and instead describes a universe in which structure, energy, fields, and relationships are always present wherever description is possible. And this presence does not appear to depend on external permission or activation. And another way to express this is that physics does not model a transition from nothing to something, but only transitions from one physical state to another. And this pattern holds across all domains of physical theory, from particle physics to cosmology. And this consistency is not accidental, and it reflects the fact that physical laws are formulated to relate states, not to generate existence itself. And when we look carefully at this, it becomes clear that the question of why existence exists may not be answerable in the same category as questions about why events happen. And this does not make the question meaningless, but it does place it at the boundary between physics and philosophy. And within physics, the most honest statement is that existence is the context in which all physical questions arise, and not an object within that context. And this reframing carries an important emotional consequence, because it removes the feeling that reality is hanging over an abyss of nothingness, and replaces it with the idea that reality is the only domain physics ever encounters. And this does not eliminate mystery, but it stabilizes it, and it shifts mystery from fear of non-existence toward curiosity about structure, pattern, and law. And when curiosity takes this form, it becomes productive rather than unsettling. And this is precisely the form curiosity takes in scientific practice. And within this practice, existence is treated as the given, and investigation focuses on uncovering how existence organizes itself. And this approach has produced extraordinary success, and nothing in that success suggests that reality is fragile, temporary, or contingent on escaping nothingness, and instead suggests that reality is deeply rooted in its own internal consistency. And this quiet realization brings us closer to a position in which the universe does not need to be defended against nothing, and does not need to justify itself by contrast with absence, and instead simply is. And this simple fact, when held gently, may be one of the most profound insights physics offers on the question of why the universe exists. At this stage, we can begin to sense a subtle shift in the emotional tone of the question, because the more carefully we examine it, the less it feels like a demand for an answer, and the more it feels like an invitation to contemplate the nature of reality itself. And this shift matters because it moves the question out of the realm of problem solving and into the realm of deep understanding. And physics, at its best, often operates in this space, where not every inquiry yields a final solution, but many inquiries reshape how we see the world. And the question of why the universe exists appears to be one of these transformative questions. And through the lens of modern physics, it gradually reveals itself as a question about structure, consistency, and possibility, rather than about emergence from nothingness. And this reframing does not remove the sense of wonder, but it changes its quality. And wonder becomes quieter, steadier, and less tied to dramatic imagery, and instead becomes a calm awareness of the depth of existence. And within this calm awareness, we can recognize that the universe does not present itself as a fragile event that barely happened, but as a persistent, self-organizing reality that has unfolded for billions of years. And this persistence is not explained by appeal to nothingness, but by appeal to internal relationships. And these relationships are what physics studies, and what physics continues to map with increasing precision. And another important aspect of this shift is that it allows us to accept uncertainty without anxiety, and to acknowledge that some questions may not have answers in the form we expect. And this acceptance does not weaken understanding, but deepens it, because it aligns our expectations with the nature of inquiry itself. And within this alignment, the idea that something exists becomes less puzzling than the idea that nothing ever could. And this inversion of intuition may be one of the quiet conceptual achievements of modern physics, and it gently leads us toward the final reflections of the series. As we move closer to the closing stages, it becomes helpful to return to the simple fact that physics always begins with what can be observed, measured, and modeled, and everything we know about the universe comes from patterns found within existence. And at no point does physics step outside existence to examine a state of non-existence. And this is not a limitation imposed by philosophy, but a direct consequence of how empirical investigation works. And this means that all physical knowledge is knowledge about something, and never knowledge about nothing. And this observation may seem obvious, but its implications are significant, because it shows that nothingness is not an object of study within physics, and therefore cannot function as a reference point for physical explanation. And when we ask why something exists instead of nothing, we are implicitly comparing a domain that physics can describe to a domain that physics cannot access. And this asymmetry makes the question difficult to ground scientifically. And recognizing this asymmetry does not dismiss the question, but it clarifies its status. And it shows that physics can meaningfully describe the structure and behavior of existence, but cannot meaningfully describe the alternative of absolute non-existence. And this naturally leads to a quiet conclusion, that within the language of physics, existence is the only domain that appears, and nothingness is not part of the vocabulary of nature. And this does not claim that nothingness is logically impossible, but it does claim that nothingness plays no role in physical description, and therefore cannot be invoked as an explanatory baseline. And this perspective aligns with everything we have examined so far, from vacuum structure to conservation laws, to cosmology to stability. And all of these point toward a universe that is self-contained, lawful, and persistent, and none of them point toward a universe that emerged from absolute absence. And with this understanding, we can approach the final parts of the series with a sense of calm continuity and without expectation of a dramatic final answer. Now, in the quiet space created by all of these considerations, we can allow the original question to rest in a slightly different form, not as why does the universe exist, but as what kind of reality is this that exists? And this change in wording is subtle but important because it moves attention away from hypothetical alternatives that have no physical representation and toward the actual features of the universe we inhabit. And those features, as revealed by physics, consistently point to a reality that is structured, lawful, and internally coherent. And this coherence is not superficial, but appears at every level of description, from fundamental particles to cosmic evolution. And this layered coherence suggests that existence is not an isolated fact, but a network of interlocking relationships. And within such a network, asking for a single external cause becomes less natural than asking how the network organizes itself. And physics answers this second question with increasing depth, and each answer reveals new patterns rather than pointing toward nothingness. And this pattern of discovery reinforces the idea that existence is not a thin surface stretched over absence, but a deep structure with many layers. And this depth can be explored indefinitely without ever encountering a boundary labeled nothing. And this does not mean that every mystery will be solved, but it does mean that mystery takes the form of unknown structure rather than unknown emergence from non-being. And this is a significant conceptual shift because it replaces the image of a universe appearing out of void with the image of a universe expressing internal consistency. And within this image, existence does not feel precarious and does not feel in need of rescue, and instead feels like the natural domain of all physical description. And this feeling of naturalness is not emotional comfort, but an inference drawn from the way physics consistently operates. And recognizing this allows us to hold the question of existence with a sense of steady curiosity rather than existential urgency. And it prepares us for the final reflections, which will not attempt to close the question, but to place it gently within the boundaries of what science can responsibly say.
As we enter the final stretch of this exploration, it becomes appropriate to acknowledge that a quiet form of realism has been taking shape throughout the series. And this realism does not insist that reality must conform to everyday intuition, and it does not claim that everything about reality is already understood. And instead, it affirms something simpler and more restrained, that there is a physical world, that it exists independently of our thoughts about it, and that it behaves according to consistent patterns that can be studied. And this form of realism is not a philosophical add-on, but the working assumption underlying all of physics. And without it, the success of scientific prediction would be difficult to explain. And this realism sits comfortably alongside the idea that certain aspects of reality are probabilistic, relational, or context-dependent. And it does not require that reality be classical in order to be real. And this compatibility is important because it shows that realism and quantum mechanics are not in conflict and instead operate at different conceptual levels. And within this quiet realism, the question of why the universe exists becomes less about whether existence itself is justified and more about how deeply structured existence is and how that structure gives rise to the world we observe. And this reframing does not provide a final metaphysical answer, but it does provide a stable orientation. And within this orientation, nothingness does not appear as a rival state waiting in the wings, and instead appears as an abstract idea with no foothold in physical theory. And existence appears as the only arena in which explanation occurs. And this orientation allows us to approach the closing thoughts of the series with calm continuity rather than expectation of revelation.
With this orientation established, we can now gently return to the phrase that has quietly guided the entire series, why something rather than nothing, and notice how differently it feels compared to when we began. Because at the beginning, the phrase may have carried a sense of sharp contrast, as if two equally meaningful options stood side by side, existence on one side and nothingness on the other. And now, after examining how physics actually treats space, energy, time, law, and structure, that contrast no longer appears symmetrical. And this asymmetry is important because existence appears everywhere within physical description, while nothingness appears nowhere. And this is not a matter of preference, but a matter of what our best theories are able to describe. And every successful physical theory begins with some form of structure, even if that structure is extremely abstract, and none begin with the absence of structure. And this consistent starting point across many branches of physics suggests that structured existence is not an outcome that must be derived from nothing, but the domain within which derivation itself occurs. And this realization slowly dissolves the intuition that existence must be explained by appeal to its opposite, and instead suggests that existence may be the most basic fact we encounter. And another way to express this is that physics does not treat being as a special case, but as the background condition for all questions. And within this background, we can meaningfully ask why stars form, why atoms are stable, why fields interact, and why the universe expands. But we do not have a physical framework for asking why being itself is present in the same operational sense. And this limitation is not an accident, and it reflects the fact that physical explanation always presupposes existence in order to function. And this does not render the question meaningless, but it places it in a different category, closer to reflective contemplation than to empirical problem solving. And this change of category matters because it prevents us from expecting a type of answer that physics is not designed to provide. And within this more accurate framing, the most honest statement we can make is not that we have solved the mystery of existence, but that we have learned that nothingness does not play an active role in physical explanation. And this learning itself is significant because it removes a false contrast that has shaped human thinking for centuries, and it replaces it with a quieter contrast between known structure and unknown structure. And this is a contrast that science is well equipped to explore. And within this exploration, existence is not treated as an anomaly, not treated as a surprise, not treated as a temporary exception, and instead is treated as the stable context in which all physical phenomena unfold. And holding this view gently allows us to approach the final part of the series not as a conclusion in the usual sense, but as a resting point, a place where the question remains open but no longer feels urgent or threatening. And this resting point reflects the deepest attitude of modern physics, which is patient curiosity grounded in structure rather than anxiety grounded in imagined absence.
With this orientation established, we can now gently return to the phrase that has quietly guided the entire series, why something rather than nothing, and notice how differently it feels compared to when we began. Because at the beginning, the phrase may have carried a sense of sharp contrast, as if two equally meaningful options stood side by side, existence on one side and nothingness on the other. And now, after examining how physics actually treats space, energy, time, law, and structure, that contrast no longer appears symmetrical. And this asymmetry is important because existence appears everywhere within physical description, while nothingness appears nowhere. And this is not a matter of preference, but a matter of what our best theories are able to describe. And every successful physical theory begins with some form of structure, even if that structure is extremely abstract, and none begin with the absence of structure.
And this consistent starting point across many branches of physics suggests that structured existence is not an outcome that must be derived from nothing, but the domain within which derivation itself occurs. And this realization slowly dissolves the intuition that existence must be explained by appeal to its opposite, and instead suggests that existence may be the most basic fact we encounter. And another way to express this is that physics does not treat being as a special case, but as the background condition for all questions. And within this background, we can meaningfully ask why stars form, why atoms are stable, why fields interact, and why the universe expands. But we do not have a physical framework for asking why being itself is present in the same operational sense. And this limitation is not an accident, and it reflects the fact that physical explanation always presupposes existence in order to function. And this does not render the question meaningless, but it places it in a different category, closer to reflective contemplation than to empirical problem-solving. And this change of category matters because it prevents us from expecting a type of answer that physics is not designed to provide. And within this more accurate framing, the most honest statement we can make is not that we have solved the mystery of existence, but that we have learned that nothingness does not play an active role in physical explanation. And this learning itself is significant because it removes a false contrast that has shaped human thinking for centuries, and it replaces it with a quieter contrast between known structure and unknown structure. And this is a contrast that science is well equipped to explore. And within this exploration, existence is not treated as an anomaly, and not treated as a surprise, and not treated as a temporary exception, and instead is treated as the stable context in which all physical phenomena unfold. And holding this view gently allows us to approach the final part of the series, not as a conclusion in the usual sense, but as a resting point, a place where the question remains open, but no longer feels urgent or threatening. And this resting point reflects the deepest attitude of modern physics, which is patient curiosity grounded in structure, rather than anxiety grounded in imagined absence.
Even as we allow the series to move toward its final moments, it is important to remain within the same calm posture that has guided everything so far. A posture that does not rush toward closure and does not attempt to force a final statement where none is available, and instead stays with the character of the question as it now appears, quieter, slower, and more refined. And in this refined form, the question of why the universe exists is no longer centered on an imagined leap from nothingness, but on the presence of structured reality itself. And this presence, as physics describes it, is not static and not frozen, but continuously unfolding, and yet always within lawful boundaries. And this combination of change and consistency is one of the most striking features of the universe, because it shows that existence is not merely present, but organized. And this organization is not superficial, but reaches down to the deepest levels of physical description. And wherever we look, we find relationships, constraints, and patterns. And these patterns are what make prediction, measurement, and understanding possible. And without them, physics could not exist as a discipline. And this observation quietly reinforces a central theme, that existence and structure are inseparable, and that structure is not something added onto reality, but something reality is. And once this is accepted, the idea of absolute nothingness becomes increasingly distant from physical relevance, because nothingness would contain no structure,
And without structure, there is nothing for physics to describe, and nothing for law to act upon, and nothing for stability to mean. And this is not a dramatic dismissal of nothingness, but a quiet recognition of its absence from the language of nature. And this recognition does not eliminate wonder, but it relocates wonder. And instead of wondering how something defeated nothing, we wonder how structure takes the specific forms it does, how laws arise as they do, and how complex behavior emerges from simple relationships. And these are questions that physics actively engages with and continues to make progress on. And this active engagement is important because it shows that while some questions may not admit ultimate answers, many deep questions still admit deeper and deeper understanding. And within this layered understanding, existence appears not as a mystery waiting to be solved once and for all, but as a reality whose richness can be explored indefinitely. And this perspective allows the mind to rest, because it removes the pressure for final justification and replaces it with steady curiosity. And this steady curiosity is perhaps the most fitting response to a universe that is vast, lawful, and quietly consistent. And it prepares us gently for the final reflections, where nothing new will be introduced, but where the shape of everything we have discussed can be held together in a single, calm awareness.
In these last moments, we can allow ourselves to hold the entire arc of the discussion in a simple, unified way, without compressing it into a slogan or a definitive answer. And what has gradually emerged is a picture in which existence is not treated as an exception, not treated as a rare event, and not treated as a fragile outcome that narrowly escaped non-being, and instead is treated as the domain within which all physical description takes place. And within this domain, physics consistently describes states, transitions, and relationships, but never describes a passage from absolute nothing to something. And this absence is not accidental, and it reflects the fact that physical theory is built to relate structured states to other structured states. And nowhere within that structure does nothingness appear as an allowable state. And this observation does not prove that nothingness is impossible in an ultimate logical sense, but it does show that nothingness is not part of the grammar of nature as currently understood. And this distinction matters because it clarifies what physics can and cannot meaningfully address, and it shows that the deepest role of physics in this question is not to explain why existence exists, but to show that existence behaves in consistent, stable, and describable ways. And when we accept this role, the question of why there is something rather than nothing changes its emotional tone and becomes less a cry for justification and more a quiet expression of wonder at the fact that there is a structured reality at all. And this wonder does not demand resolution, and it does not point toward hidden origins, and it simply acknowledges depth. And this acknowledgement is honest, restrained, and aligned with the spirit of scientific inquiry. And within this spirit, the universe is not treated as a problem to be solved, but as a reality to be understood, layer by layer. And this understanding is never finished and does not need to be finished in order to be meaningful. And with this quiet orientation, the series can gently approach its end, not with a conclusion, but with a sense of settled clarity about what can be said and what remains open. Now we reach a point where no new concepts need to be introduced.
and no additional frameworks need to be added, because everything essential has already been placed gently on the table, and what remains is simply to hold these ideas together in a calm, coherent way. And when we do this, a single, steady picture becomes visible. And that picture is one in which physical reality exists, persists, and evolves according to internal structure. And within this structure, there is no indication that existence emerged from absolute nothingness, and no indication that nothingness is a physically meaningful state. And instead, there is a consistent indication that physical law, energy, fields, and space-time form a self-contained domain. And this domain is the only domain physics ever encounters. And within this domain, explanation operates, measurement operates, and understanding grows. And this does not mean that we have reached the deepest possible level of understanding, and it does not mean that future theories will not reshape our perspective. And it simply means that based on everything currently known, the universe does not appear as a rare exception that narrowly avoided non-existence, and instead appears as a stable expression of structured reality. And this expression does not point backward toward nothing, and does not lean over an abyss, and instead rests on internal consistency. And this internal consistency is not mystical, and not symbolic, and not metaphorical. It is mathematical, empirical, and testable. And this matters because it grounds the discussion in the actual practice of science rather than in abstract speculation alone. And within this grounded context, the question of why the universe exists remains meaningful. But it remains meaningful in a reflective sense rather than a technical one. And this reflective meaning is not weaker and not less important. It is simply different, and it invites contemplation rather than solution. And this invitation is perhaps the most honest outcome of serious engagement with the question. And within this honesty, we can say something quiet and precise, that physics does not tell us why there is something rather than nothing, but it does tell us that nothingness does not appear anywhere within its descriptions. And this single fact carries significant weight because it changes how we frame the entire mystery. And when the frame changes, the emotional charge of the question softens, and the universe is no longer seen as an inexplicable accident, and is instead seen as a structured reality that simply is and continues to be. And this simple, calm recognition brings us to the edge of the series, where nothing needs to be added, and nothing needs to be resolved. And everything that can be said has been said in the only form physics can responsibly offer, which is descriptive, restrained, and open-ended. In this final moment, there is no need to draw a conclusion in the usual sense, because nothing in this exploration has been moving toward a single closing statement, and instead, everything has been moving toward a quieter understanding of the shape of the question itself, and that shape is now clear. The question of why the universe exists is not a request for a missing cause, and not a demand for an origin story, and not a puzzle that physics has failed to solve. It is a reflection of the fact that existence is the deepest context in which all other questions arise, and physics, as a discipline, operates entirely within that context and describes its structure, its patterns, and its regularities. And within those descriptions, existence appears stable, lawful, and self-consistent, and nothingness does not appear at all. And this absence of nothingness from physical description is not dramatic and not emphasized and not framed as a discovery. It is simply a quiet feature of how nature presents itself to investigation. And this quiet feature, when taken seriously, gently dissolves the sense that existence must justify itself by contrast with absence, and replaces it with the understanding that existence is the baseline of all physical explanation. And this understanding does not close the question, and it does not turn curiosity into certainty. It simply places the question where it belongs, at the boundary between what can be described and what can be contemplated. And this boundary is not a wall, and not a failure. It is a natural horizon, and horizons are not meant to be crossed. They are meant to orient us. And within this orientation, we can rest with a simple awareness that there is a universe, that it behaves in consistent ways, and that those ways can be studied, and that this fact alone is already profound, and no additional narrative is required to make it meaningful. And with this quiet awareness, the exploration can gently come to rest, not with an answer, but with clarity, and not with resolution, but with calm acceptance of the depth and subtlety of reality.
As we come to the end of this session, there's nothing you need to take with you. No ideas to hold on to, no thoughts to finish. The words can fade, just like the day slowly does. If you found this space calming, you can leave a like or subscribe to the channel. It quietly supports more moments like this. For now, let everything settle. You don't need to listen closely anymore. The sound can stay, even as attention drifts away. Rest easy, and let time continue gently on its own.